We navigate our daily lives using familiar units of measurement. We understand the world instinctively through kilometers, miles, and hours behind the wheel. But apply those everyday metrics to space, and they immediately fall apart. Take the moon. It sits about 384,000 kilometers away. Driving there at a constant highway speed of 100 kilometers an hour would take 160 days of nonstop travel. Scale out to the sun, and we use the astronomical unit, a standard measure equal to roughly 150 million kilometers. If you boarded a commercial jet flying at 900 kilometers an hour, reaching the sun would take 19 years. Mars can reach distances of 401 million kilometers when it's on the opposite side of the sun. Reaching our red neighbor in that same jet would take upwards of 50 years. At these distances, our standard tools for measuring speed and travel time become obsolete. To map the rest of the solar system, we have to look past the metrics of our home planet. At the very edge of our solar neighborhood lies Neptune, roughly 4.5 billion kilometers from Earth. Sunlight itself, racing across the vacuum at the speed of light, takes over 4 hours to reach this distant ice giant. To cross these immense gaps, humanity launched the Voyager 1 space probe in 1977. In the 4 decades since, it has covered 22 billion kilometers. It is the farthest human-made object in existence, a silent traveler in the cosmic sea. In 1990, at the suggestion of astronomer Carl Sagan, Voyager turned its camera back toward Earth. From a distance of 6 billion kilometers, it captured the pale blue dot photograph. From that vantage point, our entire world is reduced to a tiny, faint pixel of light. It reveals the reality of our physical isolation in the vastness of space. This map shows the boundary of our solar system. The microscopic center is our planetary neighborhood, surrounded by the Oort cloud, a sphere of icy objects extending 100,000 astronomical units. Beyond that shell sits Alpha Centauri, our closest neighboring star system. It's 41.3 trillion kilometers away. At this scale, the kilometer is functionally dead. Astronomers instead use the light year, the distance light travels in a single year. By that measure, Alpha Centauri is 4.4 light years away. Crossing this interstellar gap with our current technology is nearly impossible. Even at its top speed of 17 kilometers a second, Voyager 1 would need 70,000 years to reach those neighboring stars. Scaling up to the Milky Way, we find a galaxy 100,000 light-years in diameter, containing hundreds of billions of stars and their planetary systems. Within this massive structure is the human radio bubble. It is a tiny sphere extending only 100 light-years from Earth. This tiny dot represents the farthest reach of our civilization. It contains every radio and television broadcast in our history. Beyond this 100 light-year bubble, the rest of the galaxy is unaware of humanity. To any civilization residing in the vast majority of the Milky Way, we do not exist. Past the Milky Way lies the Local Group, a cluster of more than 50 galaxies spread across approximately 10 million light-years of intergalactic space. The Local Group is itself a small part of the Virgo Supercluster, a titanic structure 110 million light-years in diameter, containing thousands of galaxies. This is Laniakea, our galactic home on the grandest scale. Spanning 500 million light-years, it contains the mass of 100 million billion suns, all flowing toward a gravitational center called the Great Attractor. At this scale, the Milky Way is reduced to a microscopic speck, a single story in a grand cosmic library. And now we have reached the absolute limit of the observable universe, an immense astronomical diameter of 93 billion light-years. If the universe is only 13.8 billion years old, then light has only had 13.8 billion years to travel. How then can we see a span of 93 billion light-years? This is the result of cosmic expansion. Since the Big Bang, space itself has been stretching, physically increasing the distance between celestial bodies even as they sit within their own galaxies. Some regions of space are stretching away from us faster than the speed of light. Entire galaxies are retreating into the depths of the universe, moving out of our view forever.
We find ourselves on a small speck in an immense, expanding sea. We are physically insignificant, yet our minds have managed to map the